Good day, class. This is Sir Otep, and welcome back to our e-classroom. And on today's video, we are going to learn how to quickly distinguish polar molecules from non-polar molecules. Why do you think oil and water will not mix together? The answer is, water is a polar molecule and oil is a non-polar molecule. But what is non-polar molecule and what is non-polar molecule? We should all remember that atoms or molecules are neutral, meaning their proton, the positive charge, and their electron, the negative charge, are equal. Although molecules are generally neutral, but the distribution of positive and negative charges are not uniform. If there is an even distribution of the charges of the molecule, then that molecule is said to be non-polar. However, if the charges are not evenly distributed in the molecules, then that particular molecule is said to be polar molecule. So here are our quick ways to identify or distinguish polar molecules from non-polar molecules. Molecules that contain only one type of element is a non-polar molecule. Examples are our monoatomic gases or our noble gases such as helium, neon, xenon, and argon are non-polar. Diatomic molecules that contain only one type of element is also a non-polar molecule. Examples: N2, H2, and O2. Molecules that contain only carbon and hydrogen are also non-polar. Examples are CH4 or methane, C2H6 or ethane, and CH2 double bond CH2. Molecules that has symmetry is also non-polar. Example, carbon tetrafluoride. If we will try to see the structure of this molecule, we can observe that the central atom, carbon, is attached to the same type of atom, fluorine. Therefore, this particular molecule displays symmetry. Hence, it is a non-polar molecule. Another examples of molecules with symmetry are sulfur hexabromide, carbon dioxide, phosphorus pentachloride. If the electronegativity difference of the atoms is less than 0.5, then that particular molecule is non-polar. Example, iodine monobromide. The electronegativity of iodine is 2.5 and the electronegativity of bromine is 2.8. Their electronegativity difference is 0.3, which is less than 0.5. Therefore, iodine monobromide is a non-polar molecule. Another example is bromine monochloride. The electronegativity of bromine is 2.8 and the electronegativity of chlorine is 3.0 and their electronegativity difference is less than 0.5. Therefore, bromine monochloride is a non-polar molecule. If the molecule has hydrogen directly attached to nitrogen, oxygen, and fluorine, then that particular molecule is a polar molecule. Example, H2O or water. Water is a polar molecule because hydrogen is directly attached to oxygen. NH3 is a polar molecule Because hydrogen is directly attached to nitrogen. CH3OH is a polar molecule because again, hydrogen is directly attached to oxygen. CH3COOH is a polar molecule because hydrogen is directly attached to oxygen. If a molecule lacks symmetry, then it is a polar molecule. Examples are CH3F. We can see here that the central atom carbon is attached to 3 hydrogen and 1 fluorine. Therefore, it does not display any symmetry. So, it is a polar molecule. Another example is this particular example of a molecule is showing a lack of symmetry because carbon is attached to 2 different types of atom, the oxygen and the sulfur. Therefore, this particular molecule is a polar molecule. Another example is SO2. Sulfur is attached to 2 oxygen atoms. Although sulfur is attached to the same type of atom, oxygen, the shape of the structure of this molecule is actually a bent one. Therefore, it is also a polar molecule. And if the electronegativity difference of the atom in a molecule is more than 0.5, then that particular molecule is most probably a polar molecule. And that's it for our lesson for today. To summarize it all, here are our quick ways to identify if a given molecule is a polar or a non-polar one. For non-polar molecules, it must be 1. The molecule is composed of only one type of element. 2. The molecule is containing only carbon and hydrogen. 3. If the molecule shows symmetry. And 4. If the electronegativity difference of the atoms is less than 0.5. For polar molecules, it must be 1. If the molecule has hydrogen that is directly attached to nitrogen, oxygen, and fluorine. 2. If the molecule lacks symmetry. And 3. If the electronegativity difference of the atom is more than 0.5. And that's all for today, class. Again, this is Sir Otep, and see you on our next e-class. Take care and stay safe.